Welcome back. In this lesson, we will overview different SDN controllers. I'll try to give you a basic understanding of each controller, including the concepts behind the controller's design, its architecture, and its programming model. We'll also talk about the pros and cons of each controller to help you figure out what controller might be best suited to your needs for a particular situation. And we'll talk about ideal situations for each controller. There are many different SDN controllers, and we'll talk about the first four in this list in this lesson today. Later in the course, we'll also explore some of the other controllers listed here, including pyretic and frenetic. There are many considerations when figuring out which controller to use. One is the choice of programming language, which can sometimes but not always affect the performance of the controller itself. There's also how long it takes to figure out how to use the controller. If you're trying to do something just quick and dirty for prototyping, then you might want to use a controller with a much easier learning curve. Another thing to consider is the user base and the community support behind the controller. Finally, different controllers have different focuses in terms of the southbound APIs that are supported, the northbound API or the policy layer, whether or not there's support for OpenStack or multi-tenant cloud environments, and whether or not the controller was intended for use in education, research, or production. Let's now take a look at the first four controllers in this list. Nox was a first-generation OpenFlow controller. It is open source, stable, and fairly widely used. There were two flavors of Nox. One, Nox Classic, was the original Nox and was implemented in C++ and Python. It's no longer supported. The new Nox is C++ only. It has a fast and clean code base, and it's well maintained and supported. You can find Nox at the URL at the bottom of the slide here. In Nox, users implement control in C++. Nox itself supports OpenFlow version 1.0, and a fork of Nox called CPQD supports 1.1, 1.2, and 1.3. In Nox, the programmer writes a control program that registers for certain events, such as packet arrivals or topology changes. And the programmer then writes event handlers that respond to those different events. You might want to use Nox if you already know C++, and you're willing to use low-level facilities and semantics of OpenFlow, such as functions that directly modify the switch flow table. Another good reason to use Nox is if you need good performance. POX is essentially Nox in Python. It currently supports only version 1.0. An advantage of POX is that it's widely used, maintained, and supported, and it's relatively easy to read and write code. The main disadvantage of POX is performance. POX is the main controller that we'll be using in this course, mainly because it has a relatively easy learning curve relative to some of the other controllers, and there are some interesting policy layers, such as pyretic, that are built on top of POX. You might want to use POX if you already know or can quickly learn Python and are not concerned about controller performance. It's commonly used in research, for experimentation, and for demonstrations, as well as for learning concepts, such as the concepts that we're learning in this course. Ryu is an open-source Python controller that supports all versions of OpenFlow from 1.0 to 1.4, as well as various Nicira extensions. It also has OpenStack integration. In some sense, it aims to be an operating system for SDN, and its main advantages are the support for all these versions of OpenFlow and its OpenStack integration. A disadvantage of Ryu with respect to some of the other commercial-grade controllers is performance. Floodlight is an open-source Java controller that supports OpenFlow 1.0. It's a fork from the Beacon Java OpenFlow controller and is maintained by Big Switch. Some of the advantages include good documentation and integration with the REST API. It's also production level and provides support for OpenStack and multi-tenant clouds. However, it has a fairly steep learning curve. You might want to use Floodlight if you know Java, if you need production-level performance and support, or if you will use the REST API to interact with the controller. Another controller that is in active development is OpenDaylight. The goal of the OpenDaylight project is to provide a common industry-supported platform with a robust, extensible open-source codebase and common abstractions for northbound capabilities. OpenDaylight has many advantages, including widespread industry acceptance and integration with OpenStack and other types of cloud applications. However, it's extremely complex, the documentation is rather poor, and there's a very steep learning curve. The complexity and steep learning curve of OpenDaylight are two reasons that we're not using it as the main controller for this course. However, I've added a lecture this year to cover the basics of OpenDaylight based on a tutorial that's being provided by SDN Hub. We'll talk about that in the next lesson. Another commercial-grade controller that's worth mentioning is HP Van. Both OpenDaylight and HP Van were originally based on the source code of a controller called Beacon, and hence have many similarities both with Beacon and with each other. You might want to use OpenDaylight if you know Java, if you need production-level performance and support, if you need support for cloud applications, OpenStack, and so forth, if you need modular functions, such as the ability to plug different types of functionality, including both northbound and southbound functionality, into the same controller, or if you need applications that are already supported or implemented by vendors. We'll talk a lot more about these modules and applications that are supported by vendors in the next lesson. It's worth mentioning a library under development called Loxigen, which actually generates OpenFlow language-specific bindings for different controllers. The idea is that one could provide a wire protocol description of a control protocol, and the output would be protocol-specific bindings in different languages. Loxigen currently generates OpenFlow version 1.0 to 1.31 bindings in C for Indigo, in Java for Floodlight, in Python for OFTest, and it also generates a binding for Wireshark and Lua. In theory, one of the appeals of Loxigen is that it should support the evolvability of many different controllers. As the OpenFlow wire protocol continues to evolve, in theory, one can simply use Loxigen to upgrade the version of the OpenFlow protocol that the controller supports. In summary, there are a lot of different controllers, and your choice of controller may depend on your needs, your language, and so forth. Thus far, we've focused mainly on the controller's support for different southbound API implementations, such as different versions of OpenFlow. However, it's worth noting that southbound APIs are becoming much broader than just OpenFlow, and we'll talk about that more in the next lesson when we talk about OpenDaylight, which supports a much broader range of southbound APIs. Later in the course, we'll talk about various controllers emerging support for different kinds of northbound APIs, or policy layers that sit on top of these controllers.